as well, but is again a very small modification to get this pattern. And so I'm going to spoil it in 3, 2, 1. Basically, all we do is we add a print statement here, and this gives us the desired output. So let's just look at that, and we get the following. So again, we're going to go through the one environment diagram one more time. This one shouldn't be as bad because it's kind of a combination of the two. So the first thing we're going to do is we're going to have the call on 1, 2, 3, 4. And then what we first do now is we print. And then we do a recursive call. And then again, we print. We do a recursive call. We print. So this is the general pattern. And now we reach the base case. In the base case, we print and we return none. So this is the key thing here. So where does this none return to? The recursive call right here. And then once we return to there, we have a print statement to follow after that. And what's end there? So this is the same as our previous example. So we basically go through the same idea, and we get this entire beautiful pattern. So this is some of the cool things you can do with printing and recursive functions. We'll talk a lot more about this in the second part of this course, and particularly in part 2 of this entire computer science series when we go into data structures and algorithms, because in this actually has a lot to do with post-order, pre-order, and some interesting traversals of this data structure called trees. But obviously, you have no idea what that is. So I'm just previewing the exciting stuff to come. I'll be doing a lot of previewing of things just to get you guys hopefully excited about what's to come. All right, so let's go back to the presentation. And now, well, basically what we're going to do for the rest of the time is we're going to just do a bunch of practice questions. And these questions are somewhat challenging. Some of them are challenging, some of them are very challenging, and some of them are okay. So you're going to mix. But I'd rather spend a time on a few questions and go through them really well than go through a lot of questions at a very surface level. So I think I only have 3 questions, but they're all of various difficulties. So this first one isn't that bad, but so take some time to read through this. So basically what we have is we have our old friend combine, which if you remember we defined in our previous video. And now, remember we defined reverse previously in a pretty long function. But now what we're going to do is we're going to do it much more succinctly. Of course, not dealing with this edge case that it's zeros, just to make things easier for us. And what you'll see is that it's actually pretty easy to define recursively. So take a moment to see if you can figure this out. And you have to also use the combine function. So this is a little tricky. But anyway, I'm just going to go through it. Alright. So, what are the big steps to recursion? I haven't really talked about steps to recursion, but here I can do that. First step of any recursive problem. I've been mentioning this, but make sure that you analyze the simplest possible cases and find a solution to those. These actually end up being your base cases. Alright, so let's do that. What's the simplest possible number I can reverse? And if you look at the doc test, it's actually pretty easy to see that this case is pretty simple. If we hit reverse of 4, we return 4. Well, 4 is a 1-digit number, and if we reverse any type of 1-digit number, we know we're going to get the number itself. So that seems like a pretty good base case. So anyway, I'm just going to put that as my base case. Of course, things can always change, so I'll be ready for that if necessary. But I'm pretty confident that this is a good base case. Alright, so now, the third step really, is that we are now going to work with examples and see if we can find a larger pattern / basically our recursive formulation. That's what I'm going to call it. Oh, let me split this up into 2 lines. Okay, awesome. So, let's do that. So remember, when we were working with factorial, we started looking at some examples, and we found a pretty easy recursive definition of it. So let's first work with this example, reverse of 523. So actually, no, I'm just going to worry about 523 first. So 523 needs to somehow transform into the reverse of that, which is 325. Okay. Well, let's just start making some observations. I think one of the most interesting observations is if we look at the other example too. So I'm not going to work with the second example right now, but just so I can hit my point home, notice that it's always the case when you reverse a number that the last digit ends up being the first digit. Okay, so that's something I can work with. Oh, remember, whenever we're doing digit processing, we usually keep track of a last digit and then everything but the last, and we usually call that all but the last. You should remember this from the lump sum stuff we've been doing. So this is a pretty good intuitive way to move on. So the last digit, of course, is just going to be n modulus 10, and everything but the last digit is going to be n florative 10. Okay, so but what can I do with this? Well, in this specific case, so notice that I'm going to really work with examples. So in this 523 example, the last digit is 3. And my all but the last is what? It's going to be 32. Okay. Sorry. 52. My bad. Looking at the wrong side. Okay, so this is my all but last, and this is my last. Alright. So, somehow, if I have 52 and 3, I need to somehow get that into 325. Well, wouldn't it be nice if we could somehow reverse this, and then since we are using the combine function after all, we could take those and combine them together? Do we have a function that reverses things? Hey, we do. That's the function itself that we're trying to solve. So notice that reversing this is a lot easier than reversing this original number, 523. So reversing 52 is easier. So this is a huge part of recursion. We're trying to use the smaller problems to solve the larger problem. Okay, so this is my idea right now. I don't know if it's right, but basically, last digit plus combined with reverse of all but last. Okay, and to get that into succinct terms, basically combine the last and reverse of all but last. Okay, this seems good. Alright, so let's see if this works for this. So basically, I'm going to pull out the last digit, 6, and I'm going to reverse everything but the last. Oh, hey, that's 5, 4, 3, 2, 1. So remember, so everything but the last is 1, 2, 3, 4, 5, and all but the last reversed is going to be 5, 4, 3, 2, 1. So 1, 2, 3, 4, 5, of course, turns into 5, 4, 3, 2, 1. So the key thing here is noticing that by reversing a number, it's just taking the last digit and basically combining that with the reverse of everything but the last digit. So that's the key intuitive leap here. And so the only way that I think, not the only way, but the best way to do this is to just go through a lot of examples. So notice that I'm actively going through examples. If I was working in a test, I would be writing this out and just labeling everything I can think of to see if I can get any idea of how to solve this problem. Alright, so once we have this, the formulation is pretty clear. What's the last digit? It's just n modulus 10. And then what's everything but the last digit? It's going to be what? N divided by 10. And of course, we have to reverse that. Alright, so let's test this out. Okay. So what I'm going to do is I'm just going to do Python dot test on this. And it works. So there is the solution to this problem. So this is a pretty clever recursive formulation, especially with using the combine function. So hope you guys could have figured that out. It's okay if you can't, because after all, the most important thing is that you now know. And the most important thing overall, in my opinion, is knowing that you have like a toolbox basically. The first thing in your toolbox is that you look at the simplest possible cases, And then the next thing in your toolbox is you work with the example that they give you. Like, don't just put these examples to waste. Make sure you work with them and see if you can find a way to solve the problem using the examples. It's really hard to think of this like in a broad way. After you get some experience, something like this can become intuitive. But definitely when I was first starting out, it was important for me to work a lot with examples. So, and I think all of you will find it useful if you look at these examples and work with that in terms of them rather than in general broad cases. Because whenever you're working with examples, you feel like you're moving somewhere too. So it's psychologically also a good thing.